Hello, my dear friends. I'm Shubham from LearnoHub, the free learning platform where you can study physics, chemistry, maths, biology absolutely for free at learnohub.com. So then, let's start. So friends, as you all know, we are studying your ICSE chemistry class 10th, chapter number 5, mole concept and stoichiometry. And in the previous video of this chapter, we have studied Gay-Lussac's law and the relation between vapor density and molecular weight. Okay, so if you have missed that video, the first part of this chapter, then you must watch it because we are going to use that relation between vapor density and molecular weight in some questions to find the molecular formula. Okay, so it's very important. Now in this video, we are going to see the remaining topics, the percentage composition, empirical formula and molecular formula, and we are going to simultaneously solve the questions. After understanding each concept, we are going to solve some questions of it. Okay, so without wasting much time, let's start and let's rock. Okay, so let's start with the percentage composition of compound. Okay, so what it is, it's very simple. It is actually the percentage of each element present in the compound. Okay, and this percentage is percentage by weight. Okay, so let's understand this percentage by weight, but first of all, let's take an example. Okay, so here see, if I'm having this compound sodium carbonate, okay, so this is the percentage composition of sodium carbonate. Why I'm saying this? Because see, you are having percentage of each element, okay, of the which is present in that compound. See, percentage of sodium, percentage of carbon, percentage of oxygen, right? So I'm having percentage of each element present in the compound, and this percentage is percentage by weight. Now let's understand this thing. What is this percentage by weight? So suppose if I'm having 100 grams of sodium carbonate, then this 43.4% of sodium by weight means 43.4 grams of sodium is present, okay, out of the 100 grams of sodium carbonate. Okay, means out of 100 grams of sodium carbonate, 43.4 grams is sodium. Understood? Means roughly almost half is sodium, okay, out of this 100 grams of sodium carbonate. Then 11.3% of carbon by weight means out of this 100 gram, 11.3 gram is carbon. And similarly, 45.3% of oxygen by weight means out of 100 grams, 45.3 grams is oxygen. Understood? Now, if you would add this, you would definitely get total 100 gram. Okay. So this is what percentage by weight means. Now, suppose we have to find the percentage composition of a compound. So what we have to do is simply we have to calculate the percentage by weight of each element. Okay, percentage by weight of each element which is present in that compound, and our job is done. After finding out the percentage by weight of each element, we would write it together and that would become the percentage composition of that compound simply. But now how to find the percentage by weight of each element in a compound, right? See, so it's very simple. What you have to simply do is you have to just apply the same logic as you apply for finding out the percentage of marks in any subject, right? So suppose if you have to find out the percentage of marks in chemistry, let's take it chemistry. Okay, so what you would do is simply you would take how much marks you have scored. Let's suppose if you're smart, so you're scoring 95%, sorry, 95 marks, and then you would take total marks of the subject, right, which you can score, that is 100, and then you would simply multiply it by 100. So you know how to calculate it and you would get 95%, right? Same way you have to find out the percentage of an element by weight in a compound. So what you have to do is, see, percentage of marks in chemistry. So what you took, how much marks you scored in chemistry, okay, and then divided by total marks. Same way here we have to do, we have to take, we are here finding out the percentage of element by weight. Okay, so I would take total atomic weight, okay, of element, right, in one molecule of compound, okay, in a compound. So in one molecule of compound. See, here we are talking about one molecules, right? So that's why one molecule of compound divided by, then what is it? Total marks you have, total marks of that subject. So total weight of this molecule. Now what is the total weight of this molecule called? Molecular weight, right? So molecular weight of the compound. Molecular weight of the compound. Now both these weights, okay, total atomic weight of element in one molecule of compound and molecular weight of the compound, you have to express it in grams. And then what you have to do is simply multiply it by 100. You would get the percentage then. So this is the formula for finding out the percentage of an element in a compound by weight, or percentage of an element by weight in a compound. Very simple. So this formula you have to apply, then find the percentage by weight of each element, and then you would get percentage composition of that compound. Okay, so after learning this concept, now let's quickly solve some questions, okay, so that we could test that how much we have understood, right? So first is, this question is asked in your exams in 2020, okay? Now calculate the percentage of 1 fluorine, 2 sodium, 3 aluminium in sodium aluminium fluoride Na3Al F6. Maybe you would have heard this compound for first time, but we have to just find the percentage of fluorine, sodium and aluminium. See, fluorine, sodium and aluminium. Okay, fluorine, sodium and aluminium. Okay, which means the percentage of all the elements which are present in the compound. So in fact, they are asking us to find the percentage composition of this compound, right? Simply. Now, they are asking us to find the percentage, but to the nearest whole number. So they have made our work quite easier, right? Or else we can say that they just want the whole number as an answer, simply. Now they have given us the atomic masses of all these elements which we are going to need, right? Because what was the formula? The percentage of an element in a compound. Okay, I hope you would have noted down it. So you refer that formula, I know it, so I would just directly tell you. So percentage of an element in a compound was total atomic weight of the element in one molecule of compound divided by molecular weight of that compound, and both these weights we are expressing it in grams, okay, multiplied by 100. So what two things we need? Total atomic weight of the element in one molecule of compound, right? That we can find out. And second is also thing which we can find out, molecular weight of the compound. Okay, so we would start finding with molecular weight of compound first. So I would just start with molecular weight of this compound, Na3Al F6. Okay. Now see, those who have watched the previous video, I have explained also how to find the molecular weight and all those things. So we would just quickly go on through this. So see, 3 sodium atoms. We have been given the sodium atoms atomic weight. So 23 into 3, right? Then plus aluminium, it's 1 aluminium atom. So 27. And then 6 fluorine. So 19 6s are. Okay. So what would be the total? 69, right? 27, 79, 89, and then 99, 96, right? And 96 and this 19 6s are, it's 114. So I'm deliberately writing this also, you would know how, why. So 96 plus 114. So what it would be? 6 plus 4, 10, which means 100 and then 110. So 100 plus 110, 210, right? So 210, and I'm expressing this in grams. Okay. So this is the molecular weight of this compound. Now we would start finding out, because whatever we need, we first need the molecular weight, and then the total atomic weight of that element, particular element, we will find it on the go. Okay, one by one. So first we would find out the percentage of fluorine. Okay, 1% of fluorine in Na3Al F6. Okay, by weight. Okay, you write it entirely is equals to, now I'm not going to write the formula. Okay, total atomic weight of fluorine, right, in one molecule of that compound. So what is the total atomic weight of fluorine? See, there are 6 fluorine atoms, so I have to add the atomic weights of that 6 fluorine atoms, and then I would get the total atomic weight. So see, I have done here 6 fluorine atoms, 19 fluorine's atomic weight, one atom's weight is 19, I have multiplied it with 6, I have got 114. So see, I have got total atomic weight of fluorine in one molecule of compound. Okay, 114. And then molecular weight, so 210. Now into 100, and then I would get the percentage of fluorine in this sodium aluminum fluoride by weight. So if you would solve this, see, we can just make out from here, it's like roughly around 50%, right? 100 and 210, 114 and 210, roughly around 50%. So if you would solve this, you would get something around 53% or 54%. Okay, but the nearest whole number answer would be 54%. Okay, you can solve it by your own and then you can check, right? Next is same percentage of now sodium, okay, in Na3Al(F6) by weight. You write it completely. Same way, total atomic weight of sodium in this one molecule of compound. So say total atomic weight is 23 into 3, 69. 69, right? And then upon molecular weight, okay, and we have to express in this in grams, but this grams would ultimately get cancelled. Now multiplied by 100. So see, it's roughly around 70 and it is 210. So 71s are 73s are. It's 1/3, right? So 1/3 means 33, roughly around 33%, right? So if you would solve it, you would get the answer around 33%. The whole number answer would be 33%. And then, but don't do like this, don't do like me, you solve it, okay, completely. Just for saving time, I'm telling you to solve it on your own. I know the final answer. It would be around this 33%. Okay, perfectly around 33%. And the third one is aluminium. So same way, percentage of aluminium in Na3Al(F6) by weight, it would be total atomic weight of aluminium. Now see, there is only one atom of aluminium, so total atomic weight would be just one atom's weight, 27 by 210. Now see, it's like more than 10%, right? 21 is 10% of 210, so more than 10%, and it's less than 15%, right? So I guess it would be between 10 and 15%. So if you would solve it, you would get around 13%, okay, something like that. Yes, okay. Okay, so I hope now the first type of question you would have understood, and then you can solve it on your own. For your own practice, you can solve the similar type of question. Now let's see the another type of question, okay, which can be asked based on the percentage composition concept. So this was asked in your exams in 2017. So what it is, calculate the percentage of water of crystallization in this compound, okay, in this compound CuSO4.5H2O. Now I hope you would have studied about water of crystallization in your previous grade, right? If at all you are not remembering it, don't worry, I would just quickly tell you what it is actually, water of crystallization. See, here you can see CuSO4.5H2O. This 5 water molecules, okay, so see this 5 water molecules after this dot, okay, this water molecules are water of crystallization. Very clear? So what they are asking us to find the percentage of this water molecules, this 5 water molecules in this entire compound. Okay, how we can find it out? Same way, we have to apply the same formula. There we studied the formula for finding the percentage of an element, okay, by weight in a compound. Now here we are finding a percentage of the compound, okay, here it is water, in percentage of compound by weight in a compound, okay, in another compound, in a bigger compound. Okay, so same formula would be applied. Very simple. What it is? The total weight. Okay, now here it would be the molecular weight, because here we are finding out the percentage of the compound. Okay, this water is a compound, so percentage of a compound in another compound, right? And it's by weight. So same way, total molecular weight of that compound, okay, upon the molecular weight of entire compound. Okay, so I have just made this formula on my own into 100 in order for you to understand. Okay, this is the, what I told is just you have to apply the same concept. There we were talking about the percentage of element by weight in a compound. Here we are finding out the percentage of compound by weight in another compound. The formula pattern would remain the same. Okay, you have to just remember this thing. So what we are going to do is simply first we are going to find out the molecular weight of the entire compound. Then, so see here, molecular weight of CuSO4.5H2O. Now you would say, sir, how we are going to find out? We don't know the molecular weight of copper and all those things, right? Coppers. So see, they have given us copper's molecular atomic weight, sorry, sulfur's atomic weight, oxygen's atomic weight, hydrogen's atomic weight. Okay, so we all know hydrogen, oxygen, sulfur's atomic weight. I have told you to remember, but copper's atomic weight is given. So don't worry about the atomic weights. They definitely take care of giving you the atomic weights, okay, when it is needed to solve the question. So see, copper is 1 here, so 64. Then quickly we will add it up. Okay, sulfur is 32, 1 atom of sulfur. So I'm just taking 32. And 4 atoms of oxygen, right? We are here going to treat these water molecules separately. Okay, then you otherwise you would say, sir, there are 5 plus 4, 9 atoms of oxygen. Okay, you would just treat this 5 water molecules separately. We are just talking about first this copper, sulfur, and this oxygen. So 4 atoms of oxygen. So 4 into 16, right? 1 oxygen atom's atomic weight is 16. Atomic weight of oxygen is 16 multiplied by 4. Okay, wait. Then what it is remaining? What is remaining? See, 5 water molecules. So I'm just writing 5, and here see water's H2O. So here we are going to write it combinedly. So hydrogen is 2 hydrogen atoms. So 2 into 1. Okay, atomic weight of hydrogen is 1. 2 into 1 plus oxygen is 16. Okay, in this way. Now let's calculate quickly. So 64 plus 32 plus again 64, right? And then 5, 2 plus 16 is 18. Then moving ahead, see, I can write here 16 4s are 16 2s are 32, 16 again 4s are, right? So total, see, 4 plus 2 6 plus 4 10. So 16 10s are, so it's 160, right? This total. And then plus 18 5s are 90. So it's 250, correct? Now this 250 grams, we are just denoting it with the unit gram. So this is the molecular weight of this entire compound. Now simply we have to put into the formula. See, is equals to percentage composition, or sorry, percentage of water of crystallization. You write it in the entire sentence. Okay, in CuSO4.5H2O, okay, by weight is equals to the total molecular weight of water here. Okay, total. So there are 5 water molecules. 1 water molecule's molecular weight is, see, 18. 2 into 1 plus 16. Okay, H2O. Just if I am taking H2O, then see, 2 hydrogen atoms into 1, then oxygen is 16. So 1 molecule of water's weight is 18. Okay, so therefore I can say that molecular weight of water is 18. Now such I am having 5 molecules of water. So 5 into 18, right? We have done this here. 5 into 18, it's 90. So see, 90 upon 250 into 100. Now we would do simple calculation. See, 0 0, 25 1s are 25 4s are, and then 9 4s are 36, right? 36%. We got your answer. Okay, now moving on to the next question. So it is a little bit interesting and a tricky one. Okay, another different type of question. So a given sample, fine, has 30% ethyl alcohol by mass. Okay, and the rest being water. Rest means 70%. Okay, so we are quickly going to just go through the question, and whatever things we can understand very quickly, we are going to write it. Then determine the percentage of carbon, hydrogen, and oxygen in the given sample. They are asking us it in a given sample. So suppose they have given us this sample, right? Now how to find this percentage? Okay, how to find the percentage of elements in such sample? Okay, this is a new type for us. So we are going to simply derive the formula for finding out this percentage of element in this sample by the same type of formula which we have learned for finding out the percentage of element, okay, in a given compound by weight, right? So percentage of element, now I'm here writing carbon, hydrogen, or it can be oxygen, because here we are finding out the percentage of these three elements. Okay, now percentage of elements in given sample, right? We are deriving, or we are making a simple formula. So what it would be, what our formula was for percentage of element in a compound by weight, it was total atomic weight of the element in the given compound. So here also it would be the same, total weight of that element, okay, in the given sample. Similarly, total weight of the element in given sample divided by what would be, there it was molecular weight of the sample, because we were finding out the percentage of the element in the compound, right? And compounds, one molecule we were finding out, so that's why we are taking the molecular weight, okay, the weight of that molecule. So here we are going to take the weight of the sample, simple. So weight of given sample. Now what we are going to simply do is, then next is multiplied by 100. Okay, fine. This is our formula which we are going to use for finding out the percentage of the carbon, hydrogen and oxygen in the given sample, okay, in this question. Now let's move ahead. Now in this formula, what all things we need, we have to simply figure it out and then we have to use it. But it's not that simple how much we are thinking about, okay? It's a little bit tricky. See, what things we need? We need only two things. First is total weight of the element in the given sample, and then the weight of the given sample. That's it. But see, they haven't given us neither the total weight of the element in the given sample in case of any of the elements. See, they have not given us the total weight of neither carbon, hydrogen or oxygen in the given sample, nor they have given the weight of the given sample. Now we have to figure out on our own. But there is always a hint in the question to reach to the solution. Always. You have to just read the question carefully. See, the first sentence is the hint. What they are saying, in this given sample, 30% is ethyl alcohol by mass. Okay. So first of all, ethyl alcohol's molecular formula is C2H5OH. Okay, this is the molecular formula. You would learn about it in organic chemistry, don't worry about it. Here you have to just focus on the molecular formula for that compound. No need to know anything else about this ethyl alcohol, okay, ethanol. And what they are saying, 30% is ethyl alcohol by mass, 70% is water, okay, H2O, we know it. Now, what we can do is, for ease, we can take this weight of the sample such that we can easily find out the percentage. So if I would take it 100, this 100 and 100 would get cancelled and I would get the percentage easily, right? So I'm taking weight of the sample as 100. Okay, this is entirely 100 grams. Now what they are saying is, in a given sample, 30% is ethyl alcohol by mass, which means that out of this 100 grams, 30% is ethyl alcohol. Okay, and by mass, that's why I have taken grams. Okay, so 30% is ethyl alcohol out of the 100 grams. So what is 30% of 100 grams? 30 grams, right? So I'm just writing here 30 grams. This part is ethyl alcohol. Then the rest being water. So 70% is water. 70% of this 100 gram is water. So 70% of 100 gram is 70 grams, right? So this is the 70 gram part and this is water. Okay, I'm just denoting it with waves. So this is how our compound is. It has 30 grams of C2H5OH, ethyl alcohol, and 70 grams of water. And then total it is 100 grams of our sample. Okay, sorry if I would have said compound, it is sample. Now we are figured out about the weight of the given sample. It's 100 grams. We have taken it. But now we need to find out the total weight of the particular element in the sample in order to find out the percentage of that element in the sample, right? So let's start doing it. So first of all, we would find out the percentage of carbon. Why? Because see, once we figured out how much weight of carbon is there in the given sample, we can quickly figure out percentage of carbon in the given sample just by putting it into this formula, putting the values in this formula. Okay, so first we will start with percentage of carbon in given sample. Okay, what we have to do is, first we have to find out the total weight of carbon in the given sample. Now how we would find out? See, out of this 100 grams, how much grams is carbon? Okay, once we get the answer of this question, we got our total weight of carbon in the given sample, correct? Now how to find how much grams of carbon is there? You can quickly see, apply logic. Out of this 70 grams, which is water, is there any carbon in it? No, because water's molecular formula is H2O, no carbon. In this 30 grams, see, ethyl alcohol 30 grams, is there any carbon in it? Yes, see, C2H5OH, there is carbon. So what we want to do is simply we have to calculate in this 30 grams how much grams is carbon. Okay, once we get it, then we know that in 70 grams there is no carbon. So in total 100 grams, the amount of or the weight of the carbon would be same as that of the 30 grams. Is it clear? Right? So now let's start to find out how much grams of carbon is present in this 30 grams of ethyl alcohol. Okay, then we would get the total weight of the carbon in this 100 grams of sample. Clear? Now, how to find this? We would start with molecular weight of ethyl alcohol. Okay, in order to find that how much carbon is present in this 30 grams of ethyl alcohol. So ethyl alcohol's molecular weight you can just quickly calculate on your own and then again resume back to see if you had done it right. Okay, because now we have studied how to calculate the molecular weights in this previous video, right? So 2 into 12, 1 into 5 plus 16 plus 1. So 24, 6, 16, yes, 5 plus 1, 6 and 16. And then 30, 46 grams. Okay, now why I'm here taking it grams? Because here all the weights we are expressing in grams. Okay, we have studied in that formula as well. Okay, the percentage of the element in a given compound or in a compound by weight. There also we express it in grams. Here also we are expressing it in grams. That's why. Now what we can conclude from this molecular weight concept is, see, in this 46 grams of ethyl alcohol, okay, the carbons part is this 2 into 12, which means 24, which means out of this 46 grams of ethyl alcohol, 24 grams is carbon. Clear? Okay, so see, I'm just writing it in 46 grams of ethyl alcohol, C2H5OH. Okay, you just write the complete sentences. I'm just summarizing it. 24 grams of carbon is present. Okay, then now what we have to find is, we have developed a relationship. In 30 grams of ethyl alcohol, how much carbon would be present, right? So in 30 grams of ethyl alcohol, X grams of carbon would be present. Now we have to just calculate this value of X. So how we would do it? Same chocolate problem method. So 46 grams in 24 grams. Okay, and 30 grams in X. And 30 grams of ethyl alcohol is having X grams. Okay, direct proportion. So then find the value of X, then simply 24 into 30 by 46. Okay, so it's simple calculation. I have done it already. You can do it quickly. It's 15.65 grams. Okay, we will not waste time in calculating some simple calculations. Okay, because here we are here to study the concept, how to solve the questions. That's more important than solving just simple calculations. Okay, so you can do on your own. I am saving your time as well as my time. Okay, so how much grams of carbon we are having? 15.65 grams of carbon we are having in this 30 grams of ethyl alcohol. In this 30 grams. Okay, how much? 15.65 grams. So see, in this 30 grams we are having 15.65 grams. In the 70 grams there is no carbon. So total in 100 grams how much is there? 15.65 grams is there, right? We found out total weight of carbon in the given sample. It is 15.65, correct? So we are just putting it into this formula. 15.65 grams upon weight of the given sample is 100 grams into 100. That's it. We are calculating. Grams cancelled, 100 cancelled. What is remaining? 15.65. Okay, so 15.65%. Okay, so percent of carbon in given sample we found out, right? Was it easy? Okay, now next we are going to see how to find the percentage of hydrogen and oxygen, and it's like quite somewhat lengthy. Okay, means not lengthy, but we are going to see another aspect as well here. Okay, you would understand it. Okay, now let's find out the percentage of hydrogen in this given sample. We are going to exactly follow the same pattern how we found out the percentage of carbon in this given sample, but here we have to do just one additional thing as well. Why? Because here we have to use the logic. See, in this 30 grams of ethyl alcohol there is hydrogen, because in ethyl alcohol there is hydrogen as well, right? But in 70 grams of water also there is hydrogen, right? H2O, hydrogen is present. So we need to find out how much hydrogen is present in this 30 grams of ethyl alcohol as well as how much hydrogen is present in this 70 grams of water. And then we would add it and then we would get how much grams of hydrogen is present in this 100 grams of sample. Okay. So this means that we would get total weight of hydrogen in the given sample. Clear? Then we know the weight of the sample and then we can calculate by putting the values and solve and get the percentage of hydrogen in given sample. Okay. So let's start. I would make here 2 compartments because first we are going to find out the how much grams of hydrogen is present in 30 grams of ethyl alcohol. Okay. So this is first. Now, in order to find it, the same way, we would first start with molecular weight of ethyl alcohol. It's 46 grams, right? Now, we would figure out, see, in this 46 grams, the carbon's part is 24, hydrogen's part is 6, oxygen is 16, right? 2 into 12, 24, 5 plus 1, 6 hydrogen, 6 into 1, 6, and 16. This means that in 46 grams of ethyl alcohol, 6 grams of hydrogen is there. Right? So I would just write it here quickly in the form of relation. 46 grams of ethyl alcohol has 6 grams of hydrogen. Okay. Then, okay, 30 grams of ethyl alcohol will have X grams of hydrogen. Okay. Clear? Then we have to just find why are 30 grams, because we are finding here, okay, in 30 grams of ethyl alcohol how much gram is hydrogen. So in 30 grams, so we have just developed the relationship. Then 30 grams of ethyl alcohol will have X grams of hydrogen. Now let's just solve for the X. So 46 by 6, okay, direct proportion is equals to 30 by X. Now what would be the X? X is equals to 30 into 6, okay, by 46. Now after solving this, you would get the answer as 3.91 grams. Okay, clear? So you can calculate this thing. This is quite simple one, simple calculation. Now in the same way we are going to find out how much grams. So we found out now that in 30 grams of ethyl alcohol, 3.91 grams of hydrogen is present. See, 30 grams of ethyl alcohol, 3.91 grams of hydrogen is present. Clear? Then here, now we have to calculate in 70 grams of water, how much grams of hydrogen is present. Very simple. So again, starting with the same thing, molecular weight of water. Now we know it is 2 into 1 plus 16, right? So it's 18 grams, and here we are deliberately taking grams as the unit because we know we are going to use the weights unit as grams. So here also we are taking it as grams only. Okay. So now we can conclude here that in 18 grams of water, how much grams of hydrogen is there? Hydrogen's contribution is 2. So 2 grams, right? So I can write here in 18 grams of water, 2 grams of hydrogen is present. Okay. So then in 70 grams of water, right, we have to find out in 70 grams, right? So in 70 grams of water, X grams of hydrogen would be there. Very simple. Again, the same thing, we will solve for X. So 18 by 2 is equals to 70 by X. So X is equals to 2 into 70 by 18, right? After solving this, you would roughly get the answer around 7.78 grams. Okay. Very clear. Now what we would do is we would just simply add it. Okay. In 30 grams of ethyl alcohol and in 70 grams of water, we found out how much grams of hydrogen is there. We are going to simply add both these things and then calculate the percentage of hydrogen in the given sample. So I can write here total weight of hydrogen in given sample would be, I would just add both these things, 3.91 plus 7.78. So it would be 1 plus 8, 9, 9 plus 7, 16, 11.69. Okay, 11.69 grams of hydrogen is present in this sample. Now we will simply put this in this formula. Okay, you just write the entire formula again. What would be this? 11.69. Total weight of hydrogen in the given sample, 11.69 divided by 100 into 100. So 100 cancel, grams cancel, and our answer would be 11.69 percentage. So percentage of hydrogen in the given sample is 11.69. Now, how we found out the percentage of hydrogen in this given sample? The same way we are going to find out the percentage of oxygen in the given sample, right? Because both in ethyl alcohol, oxygen is present, as well as in water, H2O, oxygen is present, right? So first we are going to find out how much grams of oxygen is present in this 30 grams of ethyl alcohol, then how much grams of oxygen is present in this 70 grams of water, then we are going to add it, we would get total weight of oxygen in the given sample, then we are going to put that value upon 100 into 100, and then we are going to calculate the percentage of oxygen. Very simple. Now let's first start how much grams of oxygen is present in the 30 grams of ethyl alcohol. Okay, so same way, first we are talking about 30 grams of ethyl alcohol, so molecular weight of ethyl alcohol is 46, right? Now I'm not going to repeat all those steps, it's the same thing. But here, what is changing? I would just show you. See, now here, the carbon's contribution is 24, hydrogen's is 6, we know, and oxygen's contribution is 16 here, right? So this means that in 46 grams of ethyl alcohol, 16 grams of oxygen is present, correct? See, 46 grams of ethyl alcohol, 16 grams of oxygen is present. Then we have to calculate in 30 grams of ethyl alcohol, how much grams of oxygen is present, right? So then 30 grams of ethyl alcohol, x grams of oxygen is present, correct? Then we have to calculate and find out the value of this x. So 46 by 16 is equals to 30 by x. Then if you would solve the value of x, it would be around 10.43, okay, grams. So this is the value of x. So this means that 10.43, okay, here I would just rub it, x value is 10.43. So this means that 10.43 grams of oxygen is present in 30 grams of ethyl alcohol. Understood? So I would here write here 10.43 grams of oxygen is present in 30 grams of ethyl alcohol. You just write the complete sentence. Now moving ahead, let's find out how much grams of oxygen is present in the 70 grams of ethyl alcohol. Then we would add it. So molecular weight 70 grams of water, okay, and then we would add it. So here molecular weight of, we would start with water, it's 18 grams. Then what is the contribution of oxygen here? 16, correct? So out of 18 grams of water, 16 grams is oxygen. So 18 grams of water has 16 grams of oxygen, right? Then 70 grams of water will have x grams of oxygen, right? Then we would find the value for x. So 18 by 16 is equals to 70 by x. X is equals to, it would be roughly around, it would be around 62.22. Okay, so this means that 62.22 grams of oxygen is present, okay, in 70 grams of water. Now we would just add it and we would get the total grams of oxygen present in the 100 grams of this sample, right? Because this is grams of oxygen present in 30 grams of ethyl alcohol. This is the grams of oxygen, okay, present in 70 grams of water. By adding it, we would get the total grams of oxygen in 100 grams of this sample. Clear? So total weight of the oxygen in given sample would be 62.22. I'm going to just add it plus 10.43. So it would be 72.65 grams. Now simply putting this value here in this formula. So percentage of oxygen in given sample would be 72.65 grams is the total weight of oxygen in the given sample. So 72.65 grams upon 100 grams into 100 gets cancelled, gram cancelled. So what is the answer? 72.65%. Okay. Now when you would add the percentage of oxygen, and we have found out percentage of hydrogen and percentage of carbon. Okay, I hope you are noting it all down. Okay, it's very important. You have to note it down, and also you have to write those things which I have wrote in the wrote in the short forms. Okay, you have to write in the complete sentences. So by adding the percentage of oxygen, hydrogen, and carbon which we have found out, you would get that it is roughly equal to 100%. Okay, that's it. We have found out the percentage of carbon, hydrogen, and oxygen as well. Okay, now let's see the next concept. empirical formula. So what is empirical formula? So I will help you understand this concept with the help of an example. Okay, so let's take glucose. Now you would be knowing the molecular formula of glucose, C6H12O6. Okay, if you're not knowing, it's fine. Now you would have understood. Now you would have got to know. Now this glucose molecular formula, if I would write the ratio of atoms of carbon, hydrogen and oxygen. See, there is carbon, there is hydrogen, there is oxygen in this compound. So if I would write the ratio of atoms of carbon, hydrogen and oxygen, it would be, see, carbon is having 6 atoms, hydrogen is having 12, so 6 is to 12, and then oxygen is having 6, so is to 6. So I would get this ratio, 6 is to 12 is to 6. Now seeing at the ratio, you can figure out that this is a whole number ratio. But is it the simplest whole number ratio? No. We have to make it simplest then. Okay, let's make it simplest. It's very simple. See, 6 is to 12 is to 6 would become 1 is to 2 is to 1. Okay, 6 1 the 6, 6 2 the 12, 6 1 the 6. Now this becomes the simplest whole number ratio, okay, of this ratio of atoms of carbon is to hydrogen is to oxygen in glucose. Now if I would write the formula by using this simplest whole number ratio, how would that formula look like? See, in this way, carbon 1, okay, hydrogen 2 atoms, oxygen again 1 atom. Okay, so if I would just neglect this one, or I would just not write this one, okay, it's also fine. So simply I can write CH2O. Now this formula which I have derived now, that's the empirical formula, right? So see, now whatever we have done, it's same as the definition. So it's very easy for you to remember the definition as well. See, empirical formula is the formula that represents, what it is representing, simplest whole number ratio of the atoms. See here, simplest whole number ratio, okay, 1 is to 2 is to 1 of atoms, carbon, hydrogen, oxygen, okay, of the various elements. See, these are the various elements, different elements present in one molecule of the compound. See, now this is present in one molecule of the compound, right? Very clear? Understood? Now let's quickly see some small problems based on this concept. Okay, so just now we have seen the empirical formula, simple concept, how to remember the definition with the help of example. See, I also remember the definitions exactly with the help of examples which I teach you. Okay, so the same glucose example, you would remember how we figured out its empirical formula, you remember that thing, and then you develop that definition. Okay, you just remember the definition with the help of example by just correlating the example with the definition. Okay, it's very easy. Now this practice also helps us to solve the questions as well. See, because we have now also learned, by understanding the definition also, we have also learned that how to calculate or how to figure out the empirical formula from molecular formula. How? Let's see. So first is molecular formula of compound is this. Find its empirical formula. Now this was asked in your exams in 2019. So such simple 1-mark questions can be asked based on this concept. Okay. So how we are going to find the empirical formula from this molecular formula? Exactly, remember the same way we found out the empirical formula for glucose from its molecular formula. Now here they have given us this compound's molecular formula, C6H18O3. What we are going to do? First we are going to write the ratio of atoms of the different elements present in the one molecule of compound, right? So carbon is to hydrogen is to oxygen. The ratio of atoms of different elements, okay, present in the one molecule of compound. Carbon is to hydrogen is to oxygen. 6 is to 18 is to 3. Carbon 6, hydrogen 18, oxygen 3. Now what we would do is just convert it to simplest whole number ratio. This is a whole number ratio now. Okay, first we have to figure out that whether it is a whole number ratio or not. Yes, whole number ratio. Then is it simplest? See, no. So make it simplest. So 3 1s are, 3 6s are, 3 2s are. Okay, all of you know now how to make the simplest whole number ratio. So this becomes the simplest whole number ratio. Now just then write with the help of the simplest whole number ratio the formula. So C2H6O1. So I'm just writing O. So this is our answer. This is the empirical formula. Very simple. Now, such type of questions are also asked. This theoretical type of question. Very simple. Give the appropriate term defined by the statement given below. 2019. What is the statement? And what we have to do is we have to just give an appropriate term which is defined by the statement. So statement is the formula that represents simplest ratio of various elements, right? See here, the simplest ratio of various elements, right, present in one molecule of compound, present in one molecule of compound. It is simply this, which is that formula? Okay, it is the empirical formula, because this formula is representing the simplest whole number ratio of various elements, okay, and which are present in one molecule of the compound. So empirical formula, right? So once you know the concept clearly, you can answer different types of questions based on that concept. Okay. Okay, so moving ahead to the next concept of empirical formula, which is, first we saw how to find out the empirical formula from molecular formula, right? Now we are going to see how to find the empirical formula from percentage composition and atomic weights. Now here comes the use of percentage composition again, okay? And how we are going to do it? Just we would solve this question, okay? We are going to follow these two steps simply, and once we are trying to solve this question, we would solve this question and try to understand. Okay, this was asked in our exams in 2018. So the percentage composition of a gas, okay, is this: nitrogen 82.35%, hydrogen 17.64%. This is the percentage composition of the gas. Find the empirical formula of the gas. So they have given us percentage composition, they have given us atomic weights, both the things. Now how to find it? We have to just make a simple table. See, first is write the elements, okay, in first column. So nitrogen, hydrogen, this gas is having two elements, nitrogen, hydrogen, clear? Then in second column, what you do is you write the percentage composition which is given to you, okay. Now for nitrogen, the percentage by weight, okay, is 82.35%. So I'm just writing here 82.35, okay, and percentage composition is in percentage. Absolutely, we know this thing, but then too the unit we are writing. So 82.35%. I'm not denoting the unit here, that's why I have just written here above. So all the numbers here are in percentage. 82.35% nitrogen, and hydrogen is 17.64. Clear? Then in the next column, see, very simple, we have to just use the data which we are being given. We have to write the atomic weights. So nitrogen's atomic weight is 14, hydrogen's atomic weight is 1, right, given to us. Then what we have to do is we have to find out the ratio of atoms. Now how to find this? Okay, very simple, just divide this percentage composition with this atomic weight and you would get the answer. So 82.35 by 14 and you would get the answer, okay. 17.64 again divided by 1, so it would be 17.64, okay. Now whatever answer you would get it here, what you have to do is you have to find the simplest ratio. Now how to find the simplest ratio? Simply you have to take this number, okay, whatever you get after calculating this, you have to take this number here and divide it with the smallest number, okay. So I hope that, see, 14 5s are, it's 70 and 14 6s are, it's 84, right? So we would just roughly get something around 5 here, okay. So it's 5.88, okay. You calculate it on your own, you would get this. Now see, I would write here 5.88. Now what we are going to do, we are going to take this number I have told you, and then we are going to divide this number with the number which is smallest among both these two, okay. We have got these two answers in this case, right, in the ratio of atoms. One is of nitrogen, one is of hydrogen. We would take first that number, okay, nitrogen's case number, and then we are going to divide it with the smallest number. Understood? Now out of both of this, smallest number is this only. So I would again take 5.88 here. Now what I would get? Simply it's 1, right? Same number is dividing with the same number. And then next, again the same case with this. I would just take this number, okay, which we have received by calculating the ratio of atoms for hydrogen, okay, and I would then divide with the smallest number among the both of them. So smallest is again 5.88. Now you solve this, you would get 3, okay. We got the simplest ratio. What else we want? See, first we get the simplest ratio, then we have to check it whether it is a whole number ratio or not. So yes, 1 and 3 is whole number. We are not getting something in 0.5 or 3.5, 4.5 like this. 1 and 3 is whole number ratio. So see, nitrogen is to hydrogen is 1:3. Nitrogen is to hydrogen is 1:3. Now once you get this ratio, you can quickly tell the empirical formula, right? See, because we can tell nitrogen 1, hydrogen 3. In this way you can write, or you can just simply write NH3 also. So this is the empirical formula. Very easy. You have to just follow these steps. First 3 are exactly what you have been given, that you have to write. The next 2 you have to just remember how to calculate the ratio of atoms and the simplest ratio, and then check whether the simplest ratio is a whole number ratio or not, first of all. And then you have to just write the ratio and find the empirical formula. Write the empirical formula. It's very easy. Understood? Now let's see the next type of question. Find the empirical formula of the compound with the help of following. So again they have given us percentage composition and again the atomic weights. Now you would say, sir, it's the same type, right? Finding the empirical formula from percentage composition and atomic weight. But wait a minute here. See, there is a slight change, or there is a slight difference in this question. In percentage composition, we have the percentage of elements, magnesium, sulfur, oxygen, but we have also been given the percentage of water, percentage of a compound as well, right? And here in the atomic weights, they have given us the atomic weights of the elements. So here you would get confused. If you would see such question, then you would just remember that we only know how to find the empirical formula by using the percentage composition and percentage compositions of elements. We haven't studied about how to find the empirical formula by using the percentage composition of a compound, right? Don't worry, it's the exact same way we have to do. Okay, same elements we are going to write first. Which elements are given to us? Magnesium, sulfur, oxygen. Okay, and then a compound is given us. We are going to just write compound water. So now here the title would be elements or compounds, right? In this column, the title would change. That's it. Rest process would be same. Then it is atomic weights, right? Or molecular weight. So in case of elements, it's atomic weight. So magnesium's atomic weight is given 24, sulfur it's given 32, oxygen's it's 16. And yes, now water, in case of water, we would say it as molecular weight because water is a compound. So it is a molecule. Okay. So how to calculate its molecular weight? We know 1 into 2 plus 16, right? So it's 18. Very simple, right? So this is the molecular weight of water. Now again the same thing. Next would be percentage composition. Okay, so you can just change the order, no issues, but you have to remember what you have to divide with what. Okay, I hope I would suggest you not to change the order, but it's up to you. It's very simple. You have to remember that for finding the simplest ratio, you have to divide percentage composition with atomic weight. You have to remember that thing. Otherwise the order would be, you can change the order as well of writing the data. So percentage composition. Now for magnesium's case, percentage composition is 9.76. For sulfur, it's 13.01. Then for oxygen, it's 26.01, right? And then for water, it's 51.22 percentage composition. Okay, in percentages. Now, see, what we have to do is now just find the ratio of atoms, or now I would say molecules, right? Because here we are dealing with a molecule as well, right? Clear? How you are going to find out? Oh, I just went it here. Atoms or molecules. Okay. So now how you are going to find out? Simply dividing the percentage composition by atomic weight. The first step you have to remember. So 9.76 by 24. Okay. Same way 13.01 by 32. Okay. 26.01 percentage composition is divided by atomic weight 16. Okay. And then here, this is the difference, right? Different case. Here we have to divide the percentage composition by molecular weight, since it is a molecule. So 51.22 divided by 18. Now what you do is you find the answers on your own. Okay, these are the calculation part, so you can do on your own. Whatever answer you would get, we know the next step is to find the simplest ratio. So what we have to do for finding the simplest ratio, we have just now seen, okay, in the previous example. Same steps we have to follow. Whatever answer we are getting here, okay, we are going to write it as a numerator, okay, and then same here also we are getting the answers, okay, some answers we are getting after calculating in points. So let that answer be in points as well, okay, 3.58, anything. So we have to take this answer, okay, in the numerator, and out of all these answers, which is the smallest answer, you have to take it in the denominator, divide it, you would get the simplest ratio. Now you divide it on your own. I would tell you directly the simplest ratio for magnesium is 1. Same way you have to do for sulfur, okay, same way for oxygen, and exactly the same way for water as well. What you have to do, you have to take this, whatever answer you are getting in numerator, and then divide it by the number out of these 4 numbers, which is the smallest number you take here in the denominator, and divide it, and you would get the answer, okay. And what answer you would get, I would tell you. You solve it on your own. In case of water, it's 7, okay. In case of magnesium, it's 1, sulfur is 1, oxygen it's 4, okay. So this is the simplest ratio we will get. Now we have to just write it here in this ratio form. Magnesium is to sulfur is to oxygen is to water, right? Magnesium is to sulfur is to oxygen is to water. 1 is to 1 is to 4 is to 7. 1 is to 1 is to 4 is to 7. And then simply we have to write the formula, empirical formula, Mg1 S1 O4, then water 7. So see here, water is completely a molecule which we are going to write in this molecular formula. So it is here water of crystallization, okay. So water of crystallization, we write it by putting a dot. So dot, and how much water of crystallization in the empirical formula? 7, okay, 7 water of crystallization. So this is our empirical formula. Understood how to solve such type of questions? No need to worry, you have to just apply this thing, okay. In case of molecules also, the same thing you have to apply as in case of the elements. Okay, now let's see the next question. An organic compound has oxygen this much percent, hydrogen this much percent. Find its empirical formula, okay. And we have been given the atomic weights. So see, what's different in this question is, first thing, they haven't given us the percentage by weight of one element, okay, in this compound. Now they are saying that this is an organic compound first of all, but when you would study organic chemistry, you would definitely come to know that every organic compound has carbon, okay, right? It's the backbone, means without carbon there is no organic compound, very simple. But here in this organic compound, they have given us the percentage by weight of oxygen and percentage by weight of hydrogen only, okay. The percentage by weight of carbon is missing. Now very simple logic we have to apply. See, when we studied the percentage composition concept, okay, at that time I have taken the example of sodium carbonate. Now if you would go back and if you would add the percentage by weights of sodium, carbon and oxygen, you would definitely get that its sum is 100%. Understood? We have also solved one question, right, to find the percentage of carbon, hydrogen and oxygen in a given sample. There also, if you would add the percentage by weights of carbon, hydrogen and oxygen, you would get 100%. This means that if you would add percentage by weight of the elements, okay, of all the elements which are present in that particular compound, okay, then we would get 100%. By if we would add the percentage by weight of all the elements present in that compound, okay, then we would get the sum as 100%. So here also it is the same. So if I would add, now I know this compound is having carbon, okay, it is also having oxygen and hydrogen, right? These things are given to us now. Here also see carbon, hydrogen and oxygen. These 3 elements, atomic weight is given to us. So it's confirmed that it only has these 3 elements. So what I would write, percentage by weight of carbon, okay, I'm not here writing the term by weight, okay, plus percentage by weight of oxygen plus percentage by weight of hydrogen. All these 3 percentage by weights I would just combine and then I would get 100%. Their sum would be 100%. Now we have to just find out the percentage by weight of carbon simply. So percentage by weight of oxygen 26.24 plus hydrogen 4.92, okay, and I am taking this as percentage by carbon, okay. Then you have to just simply add it is equal to 100%. Then after adding it, what you would get, see, just let's try to do the quick calculation. 26.24 and 4.92. Okay, 4 plus 2, 6, 11, this one 11, 31.16. So this is 31.16. So percentage of carbon is equals to 100%, and I have added it is 31.16. So it would go there. So 100 minus 31.16. Now it would be around 100 minus 31.16, 68.84. Okay. percentage of carbon by weight. Okay, 68.84 percentage. We got this. So I'm just writing here 68.84 percentage. Okay, now what we have to do is, we know the entire process. And if I have missed telling you, or if I have misspelled this, see, we are having the percentage compositions of this compound, okay, which are all this. But individual, when we are talking about individual part, see, this is the percentage by weight of carbon. So in order to find the ratio of atoms, we are not dividing the percentage composition by atomic weight of that element. We are actually dividing the percentage by weight of that element by the atomic weight. Understood? Okay, if I would have spelled it as percentage composition divided by atomic weight, pardon me, it's the percentage by weight of that element, okay, divided by atomic weight. So here also see 68.84. Okay, in the previous questions, if I would spell that, so pardon. Now here see, percentage by weight of carbon 68.84 divided by atomic weight 12. Okay, and then we would get the ratio of atoms for carbon. Same way, percentage by weight of hydrogen divided by atomic weight, it would be simply 4.92. And then percentage by weight of oxygen, okay, divided by atomic weight. See here. So you would calculate it on your own. Then you would get some answer. Then you know how to find the simplest ratio, right? This answer which you are getting, just take it in the numerator. Out of these three answers, which is the smallest one, take it in the denominator, solve it, you would get the answer. So final answer I have written, it's 3.5 in this case. Same way, follow the same process for this and for this part as well. Okay, for hydrogen and for oxygen as well. Understood? So then you would get 3 and 1 for hydrogen and oxygen respectively. Now, why I have just chosen this question is, first of all, one thing was the percentage composition was not given of an element. Second thing is, you get a ratio which is the simplest ratio, but it is not whole number ratio. So I have told you, you have to take care before writing the empirical formula. You have to just see whether the ratio is the simplest whole number ratio or not. Okay, so here it is simplest ratio, but it is not whole number. So what I would do is, see, carbon is to hydrogen is to oxygen. Okay, carbon is 3.5, hydrogen is 3, oxygen is 1. Okay, so I have written the ratio. Now I am making the simplest ratio as simplest whole number ratio. So multiplying with 2, 7 is to 6 is to 2. So this would be the simplest whole number ratio of carbon is to hydrogen is to oxygen. Then I would simply write the empirical formula, C7H6O2. Understood very clearly? Now moving ahead to the last and the most awaited topic of this chapter, which is molecular formula. The things which we have learned so far, okay, right in the previous video as well about vapor density and molecular weight relationship, and right from this starting of this video, percentage composition, empirical formula, we are going to use it for finding the molecular formula. How? Let's see. But before that, let's first see what is actually molecular formula. Very simple. The same way I explain you everything by taking an example. So I am taking the example of same glucose, okay, C6H12O6. Now this is the molecular formula of glucose. Okay, now you can just correlate its definition with it. See, what is the definition of molecular formula? It's very simple. It is the formula that represents actual number of atoms. See, carbon is having 6 atoms, there are 6 atoms of carbon, 12 atoms of hydrogen, 6 atoms of oxygen. So these are the actual number of atoms, okay, of various elements. See, carbon, hydrogen, oxygen, okay, actual number of atoms of various elements present in one molecule of compound. Okay, very simple. We are talking about this one molecule of glucose. Clear? Now moving ahead, how to find molecular formula? It's very simple. You have to just remember two formulas for it and your job is done. And then you have to use the logic how to get back to the molecular formula. So very simple, molecular formula is equals to N into empirical formula. Okay. Now you know this what is empirical formula. Just now we have seen what is molecular formula. What is this N then? Okay. So N is a number and we get this number. How we get this number? When we divide molecular weight by empirical formula weight. Okay. And don't worry about it. We are going to see about the empirical formula weight also. But very important thing, when we find this value of N, we should make sure that it is rounded off to the nearest whole number. Okay. This one thing you have to take care of. You have to make sure that the value of N is rounded off to the nearest whole number. Okay. Which means that N should be a whole number. Very simple. Now, molecular weight and empirical formula weight. Now, interesting thing about this molecular weight is we actually all know how to find molecular weight. How? With the help of molecular formula. But here we are actually finding molecular formula. Na? We don't have molecular formula. Then how we are going to find the molecular weight? One option is they would themselves give us the molecular weight in the question itself, or they would give us vapor density. Okay. Now I hope you would correlate vapor density with molecular weight, right? We have studied that when we multiply the vapor density by 2, we get the molecular weight of the gas, right? We're talking here about the gas. Vapor density of gas, molecular weight of the gas. Correct? So they may give you vapor density, okay, if they are not giving you molecular weight directly. In some questions, this may happen. Okay, don't worry, we are going to see such questions as well. But just I'm just briefing you about how to find the molecular weight if they haven't given you. Next is empirical formula weight. Now see, empirical formula we all know. And now empirical formula weight, I think it's like you can make out on your own. See, it is simply the sum of atomic weights of all the atoms which are present, okay, of all the atoms of different elements which are present in the empirical formula. Okay, let's understand this with also example. Okay, so see this glucose, this is the molecular formula. Its empirical formula we have figured out when we were studying empirical formula. It was CH2O, right? Now what is empirical formula? See, empirical formula weight, what we would do is I would take carbon's atomic weight 12. There are 2 hydrogens. So 2 hydrogens atomic weight would be 1 into 2, right? So 2. And oxygen's atomic weight would be 60. Then I would add it. So what it would become? 14, 20, 30. 30. Now this is empirical formula weight of this CH2O. Okay. Now you can correlate this with the definition itself. See, the sum of atomic weights of all atoms. What we have done here is we have added the atomic weights of all the atoms. 1 carbon atom, 2 hydrogen atom, 1 oxygen atom, right? We have added the atomic weights of all the atoms. So sum of atomic weights of all the atoms of different elements. See, these are of different elements, correct? In empirical formula, right? We are taking empirical formula first, and then in that empirical formula, whichever different elements are there, those different elements, all the atoms atomic weight we are adding. That's it. Very clear? And we are finding out the empirical formula weight. So all these things are required for you to find out the molecular formula of a compound. Okay. Now let's see some questions and let's try to find out molecular formula. Okay. So moving ahead to the first question. A compound is found to possess carbon 40%, hydrogen 6.7%, oxygen 53.3%. Okay, so what is given to us? Compound's percentage composition is given to us, right? Now, what else they have given us? Its molecular mass is 60. Okay, so don't worry about the units while finding the molecular formula. We are not dealing here with units. Okay, just the number, molecular mass or empirical formula mass, just the number, no need to write the unit here. Okay, so find the molecular formula of the compound. And why no need to write the unit? Because we are actually going to cancel that unit when we are going to find the n, okay, value of n, because value of n is equals to, how we find out, n is equals to molecular weight upon empirical formula weight. So the unit would be getting cancelled. So we need to pay attention to the units here. So find the molecular formula of the compound. Yes, that's why we are here, right? We are going to find the molecular formula. How to find the molecular formula? I'm going to tell you the simple step which you have to follow. First, start moving from the formula itself. What is the formula for finding the molecular formula? Molecular formula is equals to n into empirical formula, right? Now just try to figure out which things have been given to you. Okay, first of all, elongate this n. Okay, extend this n. What is n? Molecular weight upon empirical formula weight. Okay, into empirical formula. Now see in the question, which things you can figure out, which things are given to you. Its molecular mass is 60, so molecular weight is given to us. Very good. Then empirical formula weight is given to us or not? See, no. Empirical formula weight is not given. Empirical formula is given? No. Okay, so now we have to find out both of these things. Now how we would find empirical formula weight? With the help of empirical formula. So this means that for finding empirical formula weight, we have to first find out empirical formula. Now how to find the empirical formula then? Is there something given to us with the help of which we can find the empirical formula? So have a closer look. For finding empirical formula, we need percentage composition of that compound and the atomic weights of the elements present in that compound. So here there are atomic weights of the elements are not given, but the elements are carbon, hydrogen and oxygen, and we know their atomic weights. But their percentage composition, but the percentage composition of the compound is given, or we can say the percentage by weight of the elements is given, which is present in the compound of all the elements. Yes, now with the help of this thing, we can find out first empirical formula, right? Once we know the empirical formula, we can find out empirical formula weight, and molecular weight is given to us. So all the three things are known, we can find out molecular formula. Okay, so let's start first finding with empirical formula. So how to find empirical formula? Now we have done like 4 or 5 questions on it. Okay, so I hope you know it very well. Okay, so elements, make that table, simple table. Which elements are there? Carbon, hydrogen, oxygen. Carbon, hydrogen, oxygen. Then percentage composition, or you can write percentage by weight also. Okay, so percentage by weight of carbon is 40%, hydrogen is 6.7%, and oxygen is 53.3%. Okay, fine. Atomic weights, next column. Carbon 12, hydrogen 1, oxygen 16. Now by the time you should remember this atomic weights. Okay, I have already told you to remember it. Then the last 2 steps which we are going to find out, which is ratio of atoms and the simplest ratio. Now I hope you can pause it here and you can find this thing on your own. Okay, so how to find ratio of atoms? Percentage by weight divided by atomic weight. 40 by 12, you would get the answer 6.7 by 1, okay, and 53.3 by 16. So this would be 6.7 itself. Rest 2 answers you find it on your own. And how to find the simplest ratio? This also you know. Okay, we have done a lot of problems finding the simplest ratio. So after finding the simplest ratio, the answer would be, I am telling you directly. Okay, 1, 2 and 1. Okay, so this would be our answer. For carbon, the simplest ratio is 1. For hydrogen, it is 2. For oxygen, it is 1. So what is the empirical formula then? See, C is to H is to O. C is to H is to O is 1 is to 2 is to 1. This means that empirical formula is C1H2O1. Okay, no need to write the 1. So this is our empirical formula. Correct? So we got our first thing, empirical formula, right? Now empirical formula weight. Simply I would write here itself empirical formula weight. You do it, you write it in the complete sentence, complete words. So what is the empirical formula weight? CH2O. So carbon 12, empirical formula weight of CH2O. You can write here. So carbon 12, hydrogen 1 into 2. Same way we just find the molecular weight. The same way we are going to find the empirical formula weight. But just the thing is, we are referring the empirical formula here. Clear? For finding the molecular weight, we are referring molecular formula. For finding the empirical formula weight, we are referring empirical formula. Very simple. The process is exactly the same. So hydrogen 1 into 2, oxygen is 16. Okay. So 12 plus 2, 14, 6, 20, 30. It's 30. So we got the empirical formula weight as well. Now it's very simple, right? We would just write again this formula. So I have already written it. On this side, you again write it. Means you should write it. Okay. Then next is put the values. So molecular weight is how much? 60. Empirical formula weight is 30. Just now we have calculated, see. Okay. And empirical formula is CH2O. Okay. This. Now here comes a slightly tricky part. You have to understand this thing. See, once we divide it, it is 2. So 2 into CH2O. So what you have to do is simply 2 into C means C2. Okay. This way. It's not conventionally math, but we just derive the molecular formula in this way. 2 into C means 2 carbons. 2 into 2 hydrogen means 4 hydrogens. So we are writing in this way, just subscript. Okay. So C2, H4 and O2. So this is our molecular formula. Okay. So this is the way we are deriving the molecular formula. So we are using the entire concept. See, percentage composition concept we are also using. Okay. Or we can say that percentage composition. With the help of percentage composition, we are finding empirical formula. Then we are finding empirical formula weight. And then we are finding molecular formula. Understood? Okay. Now let's see the next question. Find the empirical formula. Okay. And the molecular formula of an organic compound from the data given below. So this is the data given to us. Now what is this? The percentage composition of this organic compound, right? And vapor density of that organic compound is given to us. And atomic weights of the elements, okay, which are present in that organic compound are also given to us. First, we will find out empirical formula. Now we have solved a lot of questions finding the empirical formula with the help of percentage composition and atomic weight. So I have just written the data quickly here. Okay, you can just pause it here. Try solving this question on your own. I'm definitely sure that you would solve it completely. What the result you would get, what the answer you would get, I would tell you right here. Okay, so you pause it here, try on your own. Okay, so I hope you would have tried. So the right answer is, simplest ratio is carbon 5, hydrogen 5 and nitrogen 1. Okay. So the empirical formula, what it would be? C is to H is to N, carbon is to hydrogen is to nitrogen. Okay. 5 is to 1. So empirical formula would be C5H5N. Okay. Now next is molecular formula. But for finding molecular formula, we know we need 3 things. First is the molecular weight, second is empirical formula weight, and third is empirical formula itself. Now we are having empirical formula. One thing is done. Then empirical formula weight, we can calculate it from empirical formula. So second also is done. Molecular weight. Now how to figure out what is molecular weight? Because molecular weight here it is not given. But I have told you initially only that with the help of vapor density, we can find the molecular weight. Okay. Now such tricky question was asked in your ExamFear in 2019. So that's the reason I have asked you to correlate the concepts and you have to just figure out that which concept you have to use for solving the questions. Okay. So now let's move ahead to find the molecular formula. Okay. So we know that empirical formula is C5H5N, right? Now what we are going to do is, I'm just writing here the formula. Molecular formula is equals to N into empirical formula. N is molecular weight upon empirical formula weight into empirical formula. So you write it in the complete words. Okay. Don't make the short forms like me. Otherwise your marks would also get reduced. So, okay. Now let's start finding the empirical formula weight first. Okay. So empirical formula weight of C5H5N. Okay. We are having empirical formula. So with the help of empirical formula, we are going to find empirical formula weight. Simply the same way as we find the molecular weight from molecular formula. Okay, so C5H5N, so 12 5s are 60. I'm now not wasting the time, I'm directly solving it. 5 plus 14. Okay, so what it would be, the total would be 79. Okay, 70, 74, 74 plus 5, 79. Next is molecular weight. Now I have told you that molecular weight, if they haven't given you, and if they have given you vapor density, how you can find out? Just multiply vapor density with 2 and then you get the molecular weight, right? So molecular weight is equals to, we know, 2 into vapor density. Okay, I'm just writing the short form. So 2 into, what is the vapor density of the compound? 39.5. Now what is 39.5 into 2? 39 to the, it's 60, 9 to the 18, 78, right? And 0.5 into 2, 79. Okay, so molecular weight is also 79. Now what we have to do is just simply put the values, right, and solve the question. So molecular formula is equals to N into empirical formula. Molecular formula is equals to molecular weight upon empirical formula weight into empirical formula. Now molecular weight is 79, empirical formula weight is 79. Okay, you can see here, see, right, into empirical formula is C5H5N, so it is 1. So 1 into C5H5N is C5H5N. So molecular formula is also the same as empirical formula, see, C5H5N. Okay, okay, now moving ahead to the third question. So it's like slightly lengthy or a tricky one. Okay, so pay attention to this. So 0.5 grams of an organic compound contains 0.062 grams of hydrogen, 0.25 grams of oxygen. Okay, in the vapor state, this compound weighs 32 times as heavy as the same volume of hydrogen at same temperature and pressure. Okay, determine the molecular formula. So we now have to use the concepts, okay, of vapor density and molecular weight, as well as the empirical formula, the molecular formulas concept, as well as the percentage composition concept as well. Okay, so this question is like entirely a summation of all the concepts. So see how we are going to find out. For finding molecular formula, we are going to follow the simple steps. See, first, molecular formula, start with the formula itself. Whenever you have some question regarding the finding the molecular formula, you start with the formula itself. Molecular formula is equals to N into empirical formula. N is molecular weight upon empirical formula weight into empirical formula. So you would figure out that which three things you need: molecular weight, empirical formula weight, empirical formula. Any of these things, any of these three is given to us? No, you can see here. But in order to figure out each and everything, we have some or other clue. Okay, so let's start with empirical formula first. And empirical formula weight, because we know empirical formula weight we can figure out when we have empirical formula. Okay, about molecular weight, see, there is something related to vapor density given to us. Okay, we will figure it out later. It's the smaller part. First, let's figure out the empirical formula and the empirical formula weight. Okay, so starting with empirical formula first. Now, how could I figure out empirical formula from this given data? I have two things. This data, that 0.5 grams of organic compound is having so and so grams of hydrogen and so grams of oxygen. And the second one is the related to vapor density, which we are going to use for molecular weight. So how can I use this one, okay, this data, for finding the empirical formula? So try to remember, we have solved one question in which we were given a sample. And in that sample, we were supposed to find out the percentage of the elements like carbon, hydrogen and oxygen. The same way, here they have given us an organic compound. You just suppose it as a sample only. There we took the sample's weight as 100 gram. Here they have given us the sample's weight, that is 0.5 grams. So they have made things easy for us. See, so they are saying that they have given us a sample of organic compound having 0.5 grams. Okay, first I am writing this thing. Now, in this 0.5 grams, they are saying 0.062 grams is hydrogen. So, 0.062 grams is hydrogen and 0.25 grams of oxygen. So, 0.25 grams of oxygen. Now, can you figure out, see, they are saying us organic compound. We have studied in some question as well that organic compound always has the carbon, right? So the carbon's weight is here missing, right? So this thing also you have to figure out. It may not be or they may not give you the entire data which you need. Okay, you have to apply your brains and you have to figure out the data. So see, organic compound has hydrogen this much gram, oxygen this much gram. They haven't given us the carbon's weight. Okay, but we know that since carbon, hydrogen and oxygen are present in this organic compound, okay, hydrogen's gram weight is this much, oxygen's weight is this much, so rest would be the carbon's weight, right? Because only these three elements are present. Okay, so by adding both of them, okay, and then whatever addition I get, I would subtract it from 0.5 grams and I would get the weight of carbon in grams which is present in this organic compound. Okay, so let's do it. So here I'm adding it. So 2, 11 and then 3. Okay, so 0.312 grams, and now I'm subtracting this from 0.5, 0.312. Okay, so it would be 8, okay, and then 1. Okay, so 0.188 grams of carbon is there. Understood how we found out the weight of carbon? So this is weight of hydrogen, this is weight of oxygen, this is weight of carbon. Okay, let me highlight it with some other color, okay, so that it would be clearly visible to you, these three things. Now what we have to simply do is we have to find the percentage by weight of each element, okay, in this organic compound. Okay, 0.5 grams of organic compound. Once we get the percentage by weight, we know the carbon, hydrogen and oxygen's atomic weight as well. So by using the percentage by weight, which means by using the percentage by weight of carbon, hydrogen and oxygen, which means the percentage composition of this organic compound, and by using atomic weight, by using both these two things, we can derive our empirical formula, right? So let's start now. What we have to do is first percentage by weight of each element. So it's very simple. See, percentage of the element, okay, in a given sample, we have figured out the formula. It was equals to total weight of that element divided by the weight of the sample into 100. So here the percentage of the element, suppose I'm now taking carbon, okay, so here carbon in the organic compound, I'm just writing OC, okay, in organic compound is equals to the weight of carbon upon weight of the organic compound. Okay, now what is this? What is the weight of carbon? Just now we have figured out. That's why we have figured out, okay, because we need to find out the percentage by weight of carbon, hydrogen and oxygen. Okay, so weight of carbon is 0.188 by 0.5 and now into 100, okay, because here we are finding the percentage, so I missed the 100, okay, so into 100, this ratio is multiplied by 100, so this ratio is multiplied by 100, and you solve this, you would get something around 37.6%, okay, 37.6% of carbon is present. Similarly, in the same way, percentage of hydrogen and percentage of oxygen, so you write the entire formula, that percentage of hydrogen is equals to weight of hydrogen upon weight of organic compound into 100. Okay, I'm directly writing the values, 0.062 upon 0.5, okay, into 100, and here for percentage of oxygen, the weight of oxygen upon, so weight of oxygen 0.250 upon 0.5, okay, into 100. Okay, so you write the formula just like that of the, just like for carbon I have written, you write it for hydrogen, or you write it for oxygen, and then you put the values, okay, and then you solve it. So what you would get here, I can clearly make out it's 50%, okay, and the rest would be 37.650, so remaining is 12.4, yes, okay, 12.4%, okay. So this is the data which we have got now, percentage by weight of each element. Okay, now I am just writing here for my reference. Okay, or else let's now proceed further. Now we know the percentage by weight of each element, we know their atomic weights. Now let's find out the empirical formula. Okay, understood? So okay, so I have just written this basic information which we have now reached so far. The percentage by weight of each element we have just now figured out. and the atomic weights as we all know. Now next is to find the ratio of atoms and the simplest ratio, right? So I hope now you are like pro in finding out these things, ratio of atoms and simplest ratio. How to find ratio of atoms? Just take this percentage by weight of the element divided with the atomic weight. You would get ratio of atoms, okay, for all these elements. And then the simplest ratio also, you know how to find it out, okay. Now what answer you would get? I'm just writing it here, 1, 4 and 1, okay. So carbon 1, hydrogen 4 and oxygen 1. So what would be the empirical formula then? C is to H is to O, okay, C is to H is to O, 1 is to 4 is to 1, okay. So you do this, all this calculation, I just know the final answer, so I am just saving your time, saving my time, and this making crisp this video. So CH4O. So this is the empirical formula, right? We have reached so far. Now we know we got one thing, empirical formula. Now what is remaining? Empirical formula weight, right? And molecular weight. So this is done. Now empirical formula weight is like a piece of cake. So empirical formula weight, we are just finding it here itself. Empirical formula weight is equals to empirical formula of CH4O, okay, carbon 12 plus 4 into 1 is 4 plus 16, right? So 16 plus 16, 32, right? This is the empirical formula weight. Now let's move ahead to find the molecular weight, and then our job is done. Then we have to just find the molecular formula by putting all these values in the formula itself. Okay, so we have reached these two things, empirical formula weight. Now let's figure out the molecular weight with the help of this part, okay, this one. So what they are telling us is, in the vapor state, this compound, okay, weighs, so I'm just writing here mass, because I have figured out this, counted this weighs term, so I'm writing the mass of this compound. So mass of the compound now in vapor state, right? So I'm just writing here, the compound is a gas, okay, so mass of the gas, okay, weighs 32 times, so is equals to 32 times, okay, as heavy as the same volume of hydrogen. So as heavy as mass of hydrogen, so 32 times as heavy as mass of hydrogen, okay. So as heavy as, just forget about the same volume for now, so as heavy as of the hydrogen, so as heavy as the mass of hydrogen, okay, they want to tell us it is the mass of hydrogen, which 32 times as heavy as the mass of hydrogen they want to tell us. Now let's come to the volume part, as heavy as the same volume of hydrogen, okay. So this means that the mass of this hydrogen gas, okay, having a particular volume, right, V, and this volume V is same as that of this gas, okay. So this means that the mass of the gas of volume V is equals to 32 times the mass of the hydrogen having volume V, having the same volume V, exactly, okay. Now what else they have given? At same temperature and pressure. So all these things are taking place, these masses have been measured at same temperature and pressure. So now I'm writing here same temperature and pressure, both these masses. Now can you figure out this, that what actually we are trying to write down? Okay, let's make it more simpler. So what I would do is, I would just write this thing, okay, again mass of compound gas of volume V, and what I would do is equals to 32, but I would just take this term below, okay, its multiplication and into mass of hydrogen having volume V. So I would just bring it here, okay, below this term. So what it would become? Mass of hydrogen of volume V, okay. Clear? And these masses are at same temperature and pressure. Now can you just identify this relationship? We have studied the mathematical or the expression of vapor density. It was the mass of the gas of volume V, right, divided by the mass of hydrogen of volume V, and both these masses are at same temperature and pressure, and this was equals to the vapor density of the gas, right? So this means that this term is entirely vapor density of the gas, right? And this gas is actually our compound. So I'm just writing vapor density of this compound, right? So what we have figured out, the vapor density of the compound, this entire thing is vapor density of the compound, which is equals to 32. Okay. So this thing, see, they haven't given us directly in the question. They have tested us that how strong our concept is about the vapor density. What actually we know about it. So if you know the concept, if you have understood the concept, you could figure out that vapor density is 32. Clear? Okay. Now by using vapor density, see, we know the empirical formula weight. Now it's like a piece of cake to find us that what is the molecular weight with the help of vapor density. So molecular weight is equals to 2 into vapor density, right? Now vapor density is equals to 32. So 2 into 32 is 64. So molecular weight is equals to 64. Now see, we have all the things with us, right? All the three things. Now just we have to put it into the formula and find our molecular formula. So just now you can also do this thing. Molecular formula is equals to molecular weight upon empirical formula weight, right, into empirical formula. So I'm not writing the formula now. It's like I have written it so many times. I have directly substituted the values of these things in the formula. Okay, so 32 1s are 32, 2s are 64, right? 2 into C is C2 H8, 2 4s are 8, O2. So this is our molecular formula. Okay, so it was quite lengthy, but yes, it was interesting. It tested the concepts which we have learned so far, right? Okay, now let's quickly see the last question, okay, of this entire chapter. Now this was asked in your exams in 2017, okay. So what they have given us, a compound of X and Y has empirical formula XY2, okay. Its vapor density is equal to its empirical formula weight. Determine its molecular formula, okay. So now here there are no numbers as such, but the concept remains the same. The method remains the same to solve the problem. What you have to find out? Molecular formula. Again the same thing. Molecular formulas. Formula you write first is equals to N into empirical formula. Now what is N? Molecular weight upon empirical formula weight into empirical formula. Clear? Now see, they have given us a compound of X and Y has the empirical formula this. So empirical formula is given to us. Substitute it. XY2. Okay, this is the empirical formula. Then its vapor density is equal to its empirical formula weight. Now this thing they have given us. Vapor density is equals to empirical formula weight. Now we know that molecular weight is 2 into vapor density. Correct? And this they have given in the question. So now we are going to use these two things. See, molecular weight is equals to 2 into vapor density. So I'm just going to put the molecular weight as 2 into vapor density. Okay. And empirical formula weight, okay, what they have given us, it is same as the vapor density. So I will just putting this vapor density. Now vapor density cancelled. So 2 into XY2, okay, this is multiplication. So 2 into XY2, this is the empirical formula. So same logic we have to apply. X2, okay, 2 into X2 and 2 into Y, okay, 2 into Y2. So Y4, 2 2s are 4, so Y4. So this becomes our molecular formula, okay. Very simple. So such simple types of questions are also asked, but it's the thing that you should be thorough with the concept. So friends, with this we have reached the end of this video and we have studied all the concept of this chapter, right? So I hope you would have enjoyed learning with me. You would have understood all the concepts of this chapter, and we have also solved the numericals as well, which have been asked in your ICSE examinations deliberately, so that you would get a practice of how to solve the numericals as well, how to apply the concepts as well. Okay, but please do let me know this thing in the comment section, that you have enjoyed learning with me, or you have understood it or not. So stay tuned. We are going to see the next chapter in the next video, and as you all know, LearnoHub matlab free hai par best hai. So till then, bye bye and have a great day.